Okay, so come to the another theorem, theorem 10.12. Okay, so theorem 10.12 actually the converse of the theorem 10.11. Okay, so 10.12 is given that if the sum of a pair of opposite angles of a quadrilateral is 180 degree, then the quadrilateral is cyclic. So the previous theorem, it is given that in case of a cyclic quadrilateral, the sum of the opposite angles are always equal to 180 degree. The converse of this theorem is if the sum of the opposite angles, sum of the pair of opposite angles in case of a quadrilateral are equal to 180 degree, then the quadrilateral must be cyclic. Okay, so suppose we consider A, B, C, D. Okay, so we suppose A, B, C, D. Okay, so let us consider or draw. Let's consider A, B, C, D be a quadrilateral where angle this one DAB plus angle BCD equal to 180 degree, and angle suppose ADC plus angle ABC equal to 180 degree. We have to prove that quadrilateral ABCD is cyclic. Okay, we have to prove that this one. So now, actually one theorem is omitted from your syllabus, that if suppose DAB, in this case DAB was non-collinear, they are not collinear points, that means non-collinear points. So 2-3 non-collinear points, actually you can draw a circle. Suppose you draw a circle like this. Suppose you draw a circle like this. Okay, so here at first construction, here since ABCD is a quadrilateral, so quadrilateral means ABD, these 3 points must be non-collinear. Here the points A, B and D are non-collinear points. So therefore we can construct a circle. Suppose center O, we can construct a circle with center O, passing through A, B and D. Clear? So let this point be C dash and you join this one. Okay, proof. Suppose we consider this C point is not on the circle. Consider the point C is not on the circle, and another point C dash lies on the circle. Okay, so just consider that this C point is not on the circle and another point C dash actually lie on the circle. That means A, B, C dash D becomes now becomes a cyclic quadrilateral. So therefore A B C dash D is a cyclic quadrilateral. Okay. So all of you know that in case of cyclic quadrilateral, sum of the opposite pair of the angles is equal to 180. So therefore angle this one DAB, you can write BAD, angle BAD plus angle BC dash D is equal to 180 degree. Sum of opposite angles of a cyclic quadrilateral. Okay. Give number 2. So number 1 point is what actually which is given. So given things is what angle. One thing is given that BA already we write BAD plus BCD equal to 180 degree. One thing already we write. Just give number 1 on that point. Because in the given question what ABCD is a quadrilateral where the opposite angle BAD plus BCD equal to 180, we have to prove that ABCD is a cyclic. So that point is 1. So now from 1 and 2 we get both the left and right hand side are equal. 180 also left hand side must be equal. So BAD plus BCD is equal to again BAD plus BC dash D. Okay. Now look at this one. BAD cancel. That means angle BCD is equal to angle BC dash D. So one thing we got angle BAD is equal to angle. Sorry, BCD equal. So one thing we got. We just give mark 3 here. Angle BCD is equal to angle BC dash D. These two angles are equal. BCD and BC dash D. Okay, give a point 3 here. So this one is 3, number 3. Okay, now look at this triangle. Now in triangle BCC dash, this angle will be what? Exterior angle. So this angle will be sum of these two angles. Okay. Clear? So angle in this case angle BC dash D is equal angle BCC dash. This angle will be what? Sum of the opposite angles. So BCC dash plus this one is what? CBC dash. CBC dash, which will be exterior angle property. Okay, so that is BC dash D is equal to BCC dash. You can write BCD also. Same rule will recognize. Okay, again CBC dash. This one is BCC dash. BCC dash means this angle. You can write if you write BCD, then also will be this also mentioned here. So therefore that means angle BCC dash, instead of BCC dash we write just BCD. Same angle remain here. Okay, now this one BC. So you get BC dash D is equal to BCD plus CBC dash. Okay. Now look at this one BC dash D. BC dash D is equal to what? BCD. So you can write BCD and angle BCD plus CBC dash. Using bracket users but using 3. So this BCD comes to this side. That means angle BCD minus angle BCD is equal to what? Angle CBC dash. So BCD minus BCD becomes 0. Angle CBC dash. Okay. So that means we get angle CBC dash equal to 0. CBC dash, that means if this angle becomes 0, that means this C point and CD point will coincide. Because look at this one, like this one is B point, this one is C point, suppose this one is C dash point. this angle, the value of this angle becomes 0 degree, then this point, this line must be like this. That means C and C dash will be the same point. This line goes to this, so these 2 points are coincide. Clear? If the value of this angle is 0, then C and C dash must coincide. So therefore the points C and C dash must coincide. Okay, if C and C dash must coincide, that means, so therefore C point must lie on the circle. So therefore ABCD is a cyclic quadrilateral. Okay, so these two theorems are very important.